Let me take the first problem, problem number 1. Identify the interval of convergence and check that for what value of x the power series converges or diverges. The question asks that first to identify the interval of convergence of the power series. What are those intervals where the power series converges? And then we're going to check that for what value of x the power series converges or diverges. First thing is to find the interval of convergence, and then we're going to check the value of the x, that whether the power series converges or diverges for that specific value. Suppose my function f of x equals to summation of x minus 1 to the whole n over 2 to the n, where n starts from 1 up to infinity. Now you might be confused that look, we have n equals to 0. Why we have n equals to 1? Look, the series starts from n equals to 0 up to infinity. If you plug in the value of n equals to 0 here, x minus 1 to the whole 0 is 1, and 2 to the 0 is 1. 1 over 1 is 1. You're gonna get 1. So it is better to start with a 1, not with a 0. I repeat it, the series actually starts from n equals to 0 up to infinity. But based on this stuff, I want to start it from 1, not 0. As I said, when I plugged in n equals to 0 here, n equals to 0 here, I will get 1. I will get something constant. So it is better to start it from 1. Don't be confused here. But look, if you are not comfortable with n equals to 1, you can still put n equals to 0 here. It is not an issue. Whether you put n equals to 0 or n equals to 1, it is absolutely right. It is not a big deal. It is up to you. Now we know that according to the ratio test, we have limit of a sub n plus 1 over a sub n where n approaches infinity. N equals to x minus 1 to the whole n over 2 to the n. And a sub n plus 1 equals to x minus 1 to the whole n plus 1 over 2 to the n plus 1. Look to the equation. This equation is centered at 1. It's not a special case of power series where the series is centered at 0. When the series is centered at 0, we're going to have x to the n over 2 to the n. But since it is centered at 1, therefore we have x minus 1 to the whole n over 2 to the n. This whole region behaves as a sub n. What is a sub n? A sub n is actually a coefficient. So this whole region, this whole stuff behaves as a sub n. What is my a sub n? A sub n is x minus 1 to the whole n over 2 to the n. For the a sub n plus 1, you just replace n by n plus 1 here and n plus 1 here because we have a sub n plus 1. So plug in that value in the denominator and this in the numerator. So I will have limit of x minus 1 to the whole n plus 1 over 2 to the n plus 1 all over x minus 1 to the n over 2 to the n, where n approaches infinity. As I said, my a sub n is x minus 1 to the n over 2 to the n. Just plug in that value here in the denominator. A sub n plus 1 is x minus 1 to the whole n plus 1 over 2 to the n plus 1. Plug in that expression here for the numerator. Now go for further simplification to have limit of x minus 1 to the whole n plus 1 over 2 to the n plus 1 times 2 to the n over x minus 1 to the whole n, where n approaches infinity. When you pick this denominator from here and put it there to have the product with the numerator, this 2 to the n goes up and x minus 1 to the n goes down. Therefore, I have 2 to the n over x minus 1 to the whole n when you have the product of it with the numerator. Now I need something to be cancelled in the numerator and also in the denominator. So I'm going to do some kind of modifications here. When you look to this term, x minus 1 to the whole n plus 1, it is exactly like a to the n plus 1. So can I write it in the form of x minus 1 to the whole n times x minus 1 to the whole 1. Suppose my x minus 1 is a. It is like a to the n plus 1. So I can write a to the n plus 1 equals to a to the n times a to the 1. You do the same thing for the denominator here. Can I write 2 to the n plus 1 equals to 2 to the n times 2 to the 1? Yes. So I'm going to have x minus 1 to the whole n times x minus 1 to the whole 1 and 2 to the n times 2 to the n. Because both the terms has same basis. It has x minus 1 and it has x minus 1. So their powers can be added. If you add their powers, you'll get back the same x minus 1 to the whole n plus 1. Similarly here, it has base 2 and it has also base 2. So their powers can be added. you can use a single base with their powers to be added. Ultimately, you will get the same thing, which is 2 to the n plus 1. These are just minor modifications that I do because I need something to be cancelled in the numerator and also in the denominator. Now, can I cancel x minus 1 to the n with the x minus 1 to the n in the denominator? Yes. We can cancel them out. Similarly, can I cancel 2 to the n with the 2 to the n in the denominator? Yes. Cancel 2 to the n with the 2 to the n and x minus 1 to the whole n with the x minus 1 to the whole n. And the thing that I left is x minus 1 over 2. Because x minus 1 to the whole 1 is x minus 1 and 2 to the 1 is 2. So ultimately I left with the x minus 1 all over 2 modulus where n approaches infinity. Now to find the interval of convergence. For the interval of convergence, we know that if the limit value is less than 1, if it is less than 1, then the power series converges. If it is greater than 1 or equals to 1, then the power series diverges. This is my final limit value, x minus 1 all over 2 modulus. Because look, when you apply the limit, you don't have any n variable here to plug in infinity. So when you have the things other than n, your limit value will be the same thing, whatever you have here. This whole thing behaves as a constant. It is like limit of any constant. Limit of any constant is the same constant number. I repeat it, for the limit n approaches infinity, not x approaches infinity. You cannot plug in infinity for the x because n approaches infinity. Do we have any n here? No, we don't have any n. So whatever stuff you have here, it will be the value of the limit. The final limit value must be less than 1. Let me walk you through back. Look, by applying the ratio test, if the final limit value is less than 1, it should be less than 1, then the power series converges. If it is greater than 1 or equals to 1, then the power series will be diverged. For the convergence, the final limit value is less than 1. It should be less than 1. You can skip the modulus sign now. Whether you put it inside the modulus or without the modulus, it is same. Now I need the value of x and we'll check that whether the power series for that value converges or diverges. Therefore, I need to get rid of 2 in the denominator. To get rid of 2 in the denominator, I want to multiply both sides by 2. So I will have x minus 1 modulus is less than 2. Just multiply both sides by 2. When I multiply the left side by 2, 2 cancels with the 2. I will left only with x minus 1 modulus. 2 times 1 is 2. You have to multiply both of the sides by 2. This one and this one. It is like x minus 1 all over 2 modulus equals to 1. If you multiply this side by 2, you have to multiply the right side by 2 as well. Now for the interval of convergence, x minus c modulus must be less than the radius, must be less than r. X minus 1 is my x minus c and this 2 is my r. This stuff is less than 2. This r is the radius. So if x minus 1 is less than 2, on the other side, x minus 1 must be greater than negative 2. As I said, you can skip this modulus sign now, because modulus of x minus 1 equals to x minus 1. Look, x minus 1 is less than 2, which we got it from here. But on the other side, it must be greater than negative 2. So whatever value you have for the r, you have to put the same value in the negative on the other side. Less than 2 and greater than negative 2. I'm pretty much on the way to find the value of x. To find the value of x, I'm going to add 1 to all the 3 sides, to this one, and this one, and this one, to get rid of this negative 1 here. Which implies that x is greater than negative 1 and less than positive 3. Look, when you add 1 to x minus 1, you will have x minus 1 plus 1. Negative 1 cancels with the plus 1. You will left only with the x in the middle. Look, as I said, I want to get rid of this negative 1. To get rid of this negative 1, I have to add 1 here. So when I add 1, I will have negative 1 plus 1. Negative 1 cancels with the positive 1. I will left only with the x here. Similarly, you have to add the same 1 to the left side and also to the right side. Because you cannot add only 1 to the middle part. You cannot skip the left side and the right side. You have to do the same changes to all the 3 sides, to the left, to the right, and to the middle. So when I add 1 to the negative 2, I will have negative 2 plus 1. Negative 2 plus 1 equals to negative 2. Similarly, when I add 1 to the 2, I will have 2 plus 1. 2 plus 1 is 3. So I got this expression now by adding 1. This is the interval of convergence. There we got the interval of convergence of the power series. From here we can see that the power series converges between -1 and +3. But we don't know about the border values, about the -1 and about the 3, that whether the power series converges exactly on -1 and also exactly on +3. The interval is from -1 up to 3, but we are not sure about the border values, about the -1 and about the 3. To check that whether the power series converges at -1 and at +3. To do so, we're going to first plug in the value of x equals to -1 in the series. If it is less than 1, then the power series will converge. If it is greater than 1, then it will be diverged. Then I'm going to repeat the process. I will plug in the value of x equals to 3 in the series. And finally, we'll check that whether the final answer is less than 1. If it is less than 1, then the power series converges at 3. If it is greater than 1, then the power series diverges at 3. These are the values of x, -1 and +3. If I plug in x equals to -1 here, I will have f of x equals to summation of -1 minus 1 to the whole n over 2 to the n. Just plug in x equals to -1 here. If you remember, plug in the value of x equals to -1 in the main equation. Why I do this, I want to check this border value, which is the x value, to check that whether the power series converges exactly on -1 or not. So -1 will be -2. I'm going to have summation of -2 to the n over 2 to the n, which can be written as -2 over 2 to the whole n. Look, the power of -2 is n and the power of 2 is n. So I'm going to take n common here. I can write -2 to the n over 2 to the n equals to -2 over 2 to the whole n. This 2 cancels with the 2, and I will left only with the -1 inside the parentheses. I will left with -1 to the whole n. Therefore, I have -1 to the whole n. As I said, you can plug in n equals to 0 here. It is up to you whether you start the series from n equals to 0 or n equals to 1. But as I told you in the beginning, that look, when you start from the 0, you will get 1. So it is better to start from the 1. Now this equation is exactly in the form of the geometric series. We have one series which is geometric series, summation of a times r to the n minus 1. It is a geometric series. Where is my r? My r is -1. According to the geometric series, if modulus r is less than 1, then the series converges. But in case if the r modulus is equal to or greater than 1, then the series diverges. Look, as we can see here, that this series is in the geometric form. Geometric series is summation of a times r to the n minus 1. This -1 is my r. For the n minus 1 I have n. A is 1. My a, which is a constant, is 1 here. 1 times -1 to the n, but normally we don't write 1. So according to the geometric rule, if r modulus, if you take the modulus of r, if r modulus is less than 1, then the power series converges. If r modulus is greater than 1 or equals to 1, then the power series diverges. Since -1 modulus equals to 1, therefore the power series diverges at -1. As I said, that -1 is my r. So when you take its modulus, modulus of -1 is +1. Whatever stuff you put inside the modulus, it comes out as a positive. If it is negative, you're gonna get positive value. If it is positive, you're gonna get positive. So inside the modulus, -1 comes out as a positive 1. What is positive 1? Positive 1 equals to 1, not less than 1. For the series to be converged, r modulus must be less than 1. -1 must be less than 1, but since -1 modulus is equal to 1, therefore the power series diverges. It equals to 1, not less than 1. The power series diverges at -1. So we got that the first border value, which is -1, is not included in the interval of convergence. Now we're going to go for the second border value, which is 3, that whether it includes in the interval of convergence or not. So let's plug in x equals to 3. Just plug in x equals to 3 here. Look, the equation is summation of x minus 1 to the whole n over 2 to the n. For the x, we're going to plug 3, which is the value of x, to check that whether at this value the power series converges or not. 3 minus 1 is 2. I'm going to have summation of 2 to the n over 2 to the n, which can be written as 2 over 2 to the whole n. 3 minus 1 is 2. We have 2 to the n here and 2 to the n here. I can take the power n common for both of them. Just take the power n common for 2 in the numerator and also for 2 in the denominator to have 2 over 2 to the whole n. Now, 2 cancels with the 2, so I will left only with a 1 to the n. This implies that my f of x equals to summation of 1 to the n. Now, since modulus 1 equals to 1, therefore the power series diverges at positive 3. Because look, 1 modulus equals to 1. For the convergence, our modulus, which is 1 here, must be less than 1. It is equal to 1, not less than 1. Therefore, the power series diverges at positive 3. This was my interval of convergence between negative 1 and 3. But we didn't know about the negative 1 and the positive 3, that whether the power series converges or diverges. By plugging the value of x equals to negative 1, it is the value of x, it is also the value of x. We got that the power series diverges at negative 1 because according to the geometric series, our modulus must be less than 1. My negative 1, which is our modulus, equals to 1, not less than 1. Therefore, the power series diverges at negative 1. This is not this negative 1, not this negative 1, this negative 1. Don't be confused. Then we check for the other border value, which was x equals to 3. By plugging x equals to 3 here, we got at the end that 1 modulus equals to 1. According to the geometric series, our modulus must be less than 1 for the series to be converged. But since it equals to 1, therefore the power series diverges at 3, not at 1, at 3. So we can write the interval of convergence inside the parentheses, because both the negative 1 and 3 are not included. Let me check it on the number line. This is my number line. The interval is between negative 1 and positive 3. Look, on the right of the 0 we have positive values 1, 2, 3. On the left we have negative values. So from negative 1 up to positive 3, this is my interval from negative 1 up to positive 3. But I put empty circle for negative 1 and empty circle for the 3 because of this parenthesis. We have parentheses with the negative 1, which means that negative 1 is not included. Therefore, I put empty circle for the negative 1. Similarly, I have parentheses with the 3, which means that 3 is not included in the interval of convergence. Therefore, I put empty circle for the positive 3. Remember, if you have field in circle, it means that the value is included. But since both the values are not included, therefore both the values have empty circles. What about the radius of convergence? The radius of convergence will be 4. In case sometimes they may ask about the radius of convergence, like the question may ask that find the interval of convergence and the radius of convergence. The interval of convergence is negative 1, 3. The radius of convergence is 4. We have 4 points between negative 1 and 3. 1, 2, 3, 4. 4. So the radius will be 4. How many points you have between negative 1 and 3? We have 4 points. 1, 2, 3, 4. Therefore, the radius of convergence for this power series is 4. Let me walk you through back. The question asks that find the interval of convergence and then check that for what value of x the power series converges or diverges. By applying the ratio test, we got the interval of convergence. Because according to the rule, if the limit value is less than 1, then the power series converges. If it is greater than 1, then the power series diverges. If you remember, we have discussed that if the limit value is less than 1, if you set the limit value less than 1, then the power series converges. If the limit value is greater than 1, if you set it greater than 1, then the power series diverges. Since we are talking about the convergence, of the power series, so we're going to set the limit value less than 1 for the power series to be converged. Remember, the final limit value is x minus 1 over 2 modulus. This is the limit value. Because when you apply the limit on x minus 1 over 2 where n approaches infinity, you will get x minus 1 over 2. So this is the final limit value. We set the limit value less than 1 because we are checking for the power series to be converged. And then at the end we got the interval of convergence. We got the interval of convergence which is from -1 up to +3. These are the x values actually, -1 and +3, which are the border values of the interval. Now we are pretty sure that the interval is from -1 up to +3. But we are not sure about the border values which are -1 and 3, that whether the power series converges or diverges there. So to do so, we're going to plug in the value of x equals to -1 first. At the end we got -1 modulus equals to 1. Here we took help from the geometric series. We're going to take help from the geometric series here. This equation is exactly like the geometric series. It is summation of a times r to the n minus 1, where n starts from 1 up to infinity. Same thing is here, summation of -1 to the n, where n starts from 1 up to infinity. For the a, I have 1 times -1 to the n. For the n minus 1, I have n. So this -1 is my r. According to the geometric series, r modulus must be less than 1, then the power series converges. If it equals to 1 or greater than 1, then it diverges. Since -1 modulus equals to 1, which is not less than 1, equals to 1, therefore the power series diverges, not converges. I repeat it, whatever value you put inside the modulus, you will get positive value. Positive value come out of the modulus. If it is -1 modulus, you're going to get +1. If it is -2, you're going to get +2. Whatever value you put, whether it is negative or positive, a positive value come out from the modulus. So by plugging the value of x equals to -1, we saw that the power series diverges at -1. This -1 is the border value, remember. At -1, the power series diverges. And then by plugging the other border value, which was 3, we got that 1 modulus equals to 1, which is also not less than 1. So the power series diverges again here at +3. Finally, at the end, we confirmed that -1 and +3 are not included in the interval of convergence. Therefore, we put parentheses with the -1 and parentheses with the +3. On the number line, we put empty circle for the -1 and empty circle for the +3. But in case if the question asks about the radius of convergence, the question didn't ask here to find the radius of convergence, but sometimes they may ask about the radius of convergence. To find the radius of convergence, the radius of convergence here is 4. As I said, how many points we have between -1 and 3? We have 4 points. 1, 2, 3, 4. So 4 is the radius of convergence.